Experiment practical title, Miniature Commitment. To study creep transient for different materials. Aim, to study creep transient for different materials. Introduction to creep test. 1. Different materials have different properties and hence creep varies from material to material. 2. It occurs for tungsten, which has a very high melting point, at very high temperatures, while for solder, lead etc., which have very low melting points, it occurs at room temperature. Also, since the creep curve depends on various factors like obstacle density, strength etc. 3. It varies widely for different types of materials like ceramics, polymers and metals. 4. Higher the strength of a material, more is the resistance it offers to creep deformation. 5. For brittle materials, which generally do not show a plastic region, the creep deformation behavior will be much different from ductile materials. Let's study methodology 1. The experiment has been carried out using Monte Carlo simulation, in which dynamic variables are updated at each time interval with random numbers to study the
Creep is a progressive time-dependent plastic deformation where a material is subjected to constant values of load or stress. This is a typical strain versus time creep curve. In the initial stage, that is primary creep, the strain rate is relatively high, but slows with increasing strain. This is due to work hardening. The strain rate eventually reaches to minimum and becomes constant. This is due to the balance between work hardening and annealing, that is, thermal softening. This stage is known as the secondary stage or steady-state creep. This stage is most understood. The characterized creep strain rate typically refers to the constant slope in the secondary stage. Stress dependence of this rate depends on various creep analysis. In tertiary creep, which is of not much importance as far as practical applications are concerned, the strain rate exponentially increases with stress because of nicking phenomena. This rate of deformation is a function of various parameters, which are as follows. First, material properties like grain size, dislocation density, equicohesive temperature, activation energy, etc. Second, exposure time. Third, temperature. Fourth, applied load or stress.
conclusions of this creep test for different materials: aluminum, magnesium milligrams, nickel, platinum. Last study: inference of 3 materials. 1. First study. Nickel least ductile least Poisson's ratio. Experiences maximum strain. 2. Second conclusion. Aluminum and -1% magnesium see ductility between nickel and platinum with their Poisson's ratio near about 0.34. It shows medially strained. 3. Third conclusion. Platinum, it shows most ductile its Poisson's ratio. And it shows experiences least strain. Hence final inference is that aluminum and 1% magnesium starts to stabilize after 40% of the time, and platinum experiences more strain than alloy of aluminum 1% magnesium after 80% time due to continuous rise in strain experienced by platinum as compared to the stabilization experienced by aluminum 1% magnesium. All comparisons are among the 3 samples considered.